A space elevator. Doesn't that sound like something straight out of science fiction? A towering structure that stretches beyond Earth's atmosphere, connecting the planet to the cosmos. But here's the thing, this extraordinary concept isn't as outlandish as it might seem. In fact, scientists and engineers have been studying it for years, and some believe it could be one of the most transformative technologies humanity ever creates. Let's break it down. A space elevator is essentially a cable anchored to a planet or moon, extending thousands of kilometers into space. At the other end, a counterweight, typically positioned beyond what's called geostationary orbit, the point where the cable stays perfectly fixed above one spot on the planet's surface. Along this cable, climbers could move up and down, ferrying cargo, people, and equipment into orbit without the need for rockets. Why does this matter? Rockets, for all their power and sophistication, are wildly inefficient. They're expensive, polluting, and require enormous amounts of fuel just to escape Earth's gravity. A space elevator could revolutionize this process, cutting costs, reducing environmental impact, and making space travel more accessible to nations and organizations without billionaire-sized wallets. Imagine hundreds of tons of supplies sent to orbit at a fraction of the cost, research stations in space growing rapidly, lunar colonies developing faster, and even Mars missions becoming cheaper and safer. It opens the door to an entirely new era of human exploration, unlocking possibilities that were once restricted to science fiction alone. But you might be wondering, why haven't we built one yet? The short answer is materials. The cable for a space elevator would need to be unbelievably strong, stronger than anything currently available. Scientists have been exploring options like carbon nanotubes and graphene, materials with nearly unmatched strength-to-weight ratios. But the manufacturing and scalability of these materials remain enormous hurdles. Even if we figure out the cable, there are other challenges. How do you defend such a delicate structure from debris in space or unpredictable weather on Earth? How do you stabilize a system stretching tens of thousands of kilometers? And of course, how do you convince governments and the private sector to collaborate on what would likely be one of the most expensive engineering projects in history? Yet, despite the obstacles, progress is being made. Researchers are actively working on small-scale prototypes and identifying potential sites for elevators, like the equatorial regions of Earth, which offer stability due to the planet's rotation. Meanwhile, space elevators on the Moon or Mars might be easier to build thanks to their weaker gravity. Think about this. As humanity reaches for the stars, the space elevator could become the bridge between Earth and its celestial future. It embodies the dream of turning impossibility into reality and could ultimately reshape our relationship with the universe itself. The question is, will humanity rise to the challenge?